Hello everyone, I am Samidhi from CSE AML. Today I am going to present my project on adaptive learning path. It mainly focuses on helping students learn better by adapting questions by their expressions. Project overview. Develop a real-time adaptive learning system that detects and responds to the user emotion state during interaction. User interact with a quiz interface while system monitors facial expressions through a webcam. A trained transformer model classifies emotions based on facial landmarks extracted using MediaPipe. If a negative emotion is detected, an easier task is suggested, which can be approved or modified by therapist. The system aims to enhance learning outcomes by adapting content based on emotional engagement. All user interaction, emotions, and performance data are stored and tracked for personalized feedback. Here is a architectural diagram. In beginning, we had three parts. Front end. We used React.js. It shows quiz screen, webcam input from user. Media pipe tracks user facial expression through webcam. It gives 468 facial landmarks. Backend. Landmark data is sent to backend through API call. Backend then sends this data to transformer model. And then we modified it. We have included therapist approval. If system detects sad emotion, it doesn't just change suggestion and therapist can approve it. We have in previous we used local data storage. Now we are using Mongo Atlas, a cloud database. A API for frontend sends facial landmarks to predict API. Backend detects the predicted emotions. Store API saves all the questions, answers, timestamps, and emotions. Emotion detection model implemented a transformer based neural network using PyTorch for emotion recognition. The model was initially trained on facial expression recognition dataset and then made a model trained on custom dataset on facial landmarks. Each face is represented as 936 dimensional feature vector. The model architecture includes positional encoding, multi-head self-attention, feed-forward layers, and layer normalization. We have achieved 55% accuracy on custom dataset and 25 approaches of training. Designed to work in real time by taking webcam input, extracting landmarks, and returning the predicted emotion. For frontend, we have used React.js. It includes login screen, quiz or game interface, and shows the user's detected emotion. We integrated MediaPipe to continuously track facial landmarks from the webcam. This data is sent to the backend using REST API calls. There are two main API endpoints, predict and store. Predict sends facial landmarks data to backend and receives the predicted emotion, like happy, sad, confused, or both. Stores the emotions with responses in MongoDB for tracking progress. Everything works in real time. As a user interacts, the webcam updates, emotion is detected, and date. And based on that, the system can adapt what question is shown next. Challenges. We built a complete working pipeline from a real-time machine learning model to a user-facing quiz interface. Understood how transformer model can be adapted to work on facial landmarks data. Got hands-on with MediaPipe, building REST APIs and connecting everything with a cloud database. Also learn how to make a full stack project run smoothly with multiple tech stack involved. Challenges we faced. The FER dataset had 7 emotions while our custom data had only 6. We had to figure out how to handle that while training. Getting MediaPipe to work in real time with webcam access and sending data smoothly to backend wasn't easy. React's asynchronous nature made it tricky to handle emotion detection. The original plan didn't include therapist approval, but we added that feature later to make it more practical. We also moved from a local MongoDB setup to Mongo Atlas so our whole team could access the data easily and work remotely. FER is a large, well-known dataset of labeled facial emotion images. We used it for pre-training so that model could learn general emotion patterns. Our app uses landmark vectors as input, so we collected our own data using MediaPipe. We pre-trained our FER and custom dataset, but used FER trained model for our application. Here are code snippets, emotion detection endpoint. Front-end sends facial landmarks to predict. It converts model understandable. Sends to transformer model which predicts emotion. We get emotion like happy, sad. Send it back to JSON response. This happens while user is answering. Next, it builds PyTorch. It takes 936 dimensional input like facial landmarks. First converts input into format where transformer can understand. Passing through layers, emotion is detected. Integration with backend. Takes landmarks from webcam, send to backend using fetch, calls, predict, and wait for emotion. Once it get used to the send to quiz. Next, store emotion and quiz data. It stores data like user input, emotions, question ID, timestamps. Deployment decisions. Our flags backend runs locally, but it can also be deployed on services like Render if needed. We use MongoDB Atlas for our database instead of local DB since it's cloud-based and easier for collaboration. The front end is React-based. Emotion detection from webcam in real time is working. Adaptive quiz interface is working. Therapist confirmation added and functional. Full integration between front end, back end, and database. Data tracking and logging of responses and emotions is completed. Here you can explore our project on GitHub. Here is a working demo. First, we need to log in as therapist. And then here is a dashboard of therapist. Here, therapist can see total students, sessions, active assignments, and performance of the student. In student, they can see their subjects. Here we can assign games. So we select the student and we can select the game. We need to assign the game to the student. Here, student need to log in. They can select whichever game they want to play. Here we have selected memory match game. So we need to match this. So we can see here our total score, emotions detected, our performance. So while attempting the quiz, here our emotion is detected. If we are sad, the question level will be decreased, difficulty level will be decreased. If we are able to answer quick, then the difficulty level of question will be increased. So based on this, here we have analyzed performance of the student. So here is another challenge. So here we can see the performance of the student. In the therapist dashboard, he can assign the game and he can see the student's performance. Thank you.